Here are some tips for graphing polar roses, looking at the practice graphs on the back of the notes. So our first one is 6 cosine of 2 theta. So recall from what we observed before that the number on the outside of the function tells us the length of the petals. So the length of the petals here are 6. The number on the inside of the function, the 2, tells us the number of petals. If it's even, we double it. So the number of petals is 4. Now the cosine has its maximum value when at the angle 0. Cosine of 0 is 1, so that means that we're going to always start at 0 for a cosine graph, for it's the first petal. So if the petal is 6 units long, then I'm going to have a petal at 6 units long at 0. Since there are 4 petals, there are going to be 4 petals evenly spaced, all at 6 units long. So I'm going to put one of them at pi over 2, one of them at pi, and one at 3 pi over 2. So this one's a fairly easy one to do because of it being cosine. Okay, so those, and I'm not too worried about how thick the petals are. They're just as long as I have 4 petals and they're the correct length and the first one starts in the correct space. Here, the length of the petals is 10, and the number of petals is 8 because it's 2 times 4. Now with sine, though, we have to recognize that sine of pi over 2 equals 1. So we want to figure out where does 4 theta equal pi over 2. That would give us our maximum value, which would be the tip of where the first petal starts. So theta is equal to pi over 4 times 2. Pi over 2b, which is pi over 8. So the first petal starts at pi over 8. Well, this value right here is pi over 4. So halfway would be pi over 8. So my first petal is going to start at pi over 8, which is right there. And it's 10 units long. Now to help me graph my petals, I'm going to recognize that I'm going to kind of divide up this graph. Every place there's a pi over 4, and realize that there's going to be a petal halfway in between all of these marks. So there's going to be a petal here and here, here, all the way around, halfway between an axis and the pi over 4 angle. So here are my 8 petals. The more petals they are, the thinner they are. They don't overlap each other. So as you get more petals, they become skinnier. So here is graph number 2. Okay, now we're getting into a little more complicated ones because we're looking at negative 6, 3 theta, sine of 3 theta. So I usually like to figure out what positive 6 sine of 3 theta is first and then flip it. Okay, so I know that my length of my petals is 6. Number of petals, this is an odd number, so the number of petals is just 3. We don't double it. And then the starting value, theta starts at pi over 2 times b, which is pi over 6, pi over 2 times 3. That's not terribly clear. Let me make that a little neater for those of you taking notes. 2 times b, which is pi over 2 times 3, pi over 6. Okay, so now this would be if r is positive. Okay, so this is if if a is positive. So if the 6 is positive, but the 6 is not positive. So this is not where my graph is actually going to be, but I'm going to use this as reference. So I'm just going to put a little dot there, that this is my starting point. And then every other petal is going to be 120 apart. So if I have one here, I'm going to have another one here and another one here. These are all going to be 120 apart. So I'm just going to make a little dot. There's another petal here, and my third petal is going to be, no, I did that wrong. Take that back. 120 away would be a petal straight down, and then the other petal is going to be right there at 5 pi over 6. So that would be where the 3 petals would be located if 6 were positive. But since 6 is negative now, I'm going to go 180 degrees opposite each one of these points. So there'd be a point at 7 pi over 6, a point at 11 pi over 6, and a point at pi over 2. And here would be my graph. Okay, so the red dots are just kind of for a frame of reference before I make everything negative, before I make all my R values negative. So by making -6, basically it takes all my R values the opposite direction of the way they were. I'm going to do the same thing for my cosine graph. My cosine graph, I know that I've got 5 petals of length 5. And if it were a positive 5, cosine would start at 0. So I'd have a petal here, and then I'd have them evenly spaced 5 petals. But since this is not a positive 5, instead of starting at 0, and I should make that red to kind of do the same thing I did last time, instead of starting at 0, I'm going to be going the opposite direction, and I'm starting at 5 pi. Now, how do I make these petals go every evenly spaced with 5? Well, if you think about 360 divided by 10 is 36, so 360 divided by 5 is 2 times 36, or 72 degrees. So if you can kind of imagine going about 70 degrees, so maybe about right here-ish, and maybe going the other way about there, and then trying to make them look sort of evenly spaced. I'm totally just, that's actually not too bad. I'm just making sort of a general sketch here. As long as the first petal's in the right place, I'm not all that picky about where the other ones are, but that would be about what it looks like. Okay, so hopefully that's helpful in graphing, and also showing you that I'm not being terribly picky about the specific location of hard to place points.